Sometimes the biggest secrets are hidden in the most obvious places. Today, we're going to dig into one of the most common materials on the planet to uncover something, well, something world-changing. Let's get into it.
Yeah, sounds pretty out there, right? But what if the answer is actually way, way simpler than we thought? We're going to look at how plain old sand, or really the silicon that's in the sand, is at the center of not one, but two huge energy breakthroughs.
Okay, so first things first. To really get why this is such a big deal, we need to talk about the problem. And it's a huge bottleneck, one that starts with the batteries that run basically everything in our lives.
Think about it. Your phone, your laptop, your EV if you've got one, they all run on lithium-ion batteries. And inside those batteries, the anode, which is the part that actually holds the charge, is almost always made of graphite. Now, graphite's been great, it's reliable, but we've basically hit a wall. We've squeezed every last drop of performance out of it, and that's what's holding us back from the next big leap.
So, if graphite is the problem, what's the answer? You might think it's some super rare, crazy expensive new element, but you'd be wrong. The solution is something you've probably seen a million times.
Yep, silicon. It's the second most common element on Earth. It's the main ingredient in sand, it's cheap, it's everywhere, and for a long, long time, scientists have known that this stuff has insane potential for batteries. The big puzzle has always been, how do we actually make it work?
And that brings us to the first part of our story. We're going to have to zoom way, way in, down to the microscopic level, deep inside the battery. Because this is where you see why silicon is both this incredible powerhouse and a massive headache.
10 times. Let that sink in for a second. Silicon can theoretically store 10 times more energy than the graphite we use today. Just imagine what that means for a second. We're talking EVs that could go for hundreds and hundreds more miles. Phones that last for days on a single charge. It's not just an improvement, it's a total game changer.
But of course, there's a catch, right? If it was that easy, all our batteries would already be using silicon. The truth is, this tiny titan has a tragic flaw. A self-destructive habit that's kept it on the sidelines for years.
400%. This is the problem, right here. When silicon charges up and absorbs all those lithium ions, it blows up to 4 times its original size. Imagine taking a deep breath and having your lungs expand to 4 times their normal size every single time. It's not sustainable.
And that constant violent swelling and shrinking is just catastrophic for the battery. The tiny silicon particles literally shred themselves to pieces. They crack, they crumble, and all those crucial electrical connections just break. The result? The battery dies, and it dies fast.
So the big question is, how do you tame this beast? Well, scientists are coming up with some seriously clever fixes. They're creating these incredible molecular glues, or advanced binders, that literally hold the silicon particles together as they expand. Or they mix silicon with carbon to build a kind of strong, flexible cage around it. And some of the coolest stuff involves nanostructures, designing these tiny porous sponges or shells that give the silicon room to expand and contract safely without tearing itself apart.
Okay, so that's the tiny, microscopic story. Now I want you to zoom all the way out with me. We're going from the inside of a battery to the massive, grid-level scale of powering entire cities. And what's wild is that sand is the hero of this story too, but in a totally different and honestly much simpler way. And no, this is not some far-off science fiction concept. This is real, it's happening right now. In Finland, the world's first commercial sand battery is up and running. And the idea behind it is, well, it's almost ridiculously simple. It's basically a huge insulated steel tank filled with nothing more than plain old sand. Okay, so how on earth does a tank of sand work as a battery? Well, the process is pretty elegant. You start with cheap, excess electricity, like on a really sunny or windy day. You use that power to heat the sand up, and I mean really hot, like over 1,000 degrees Celsius. That giant insulated silo is so good it can store that intense heat for months with barely any loss. Then, whenever you need the power back, you just pump air or water through pipes running through that superheated sand. That fluid gets incredibly hot, turns into steam, and spins a turbine to generate electricity. Simple as that. And you can see that whole cycle right here. Electricity comes in from renewables, gets turned into thermal energy, heat, which is stored in that mountain of sand. When you need it, a heat exchanger pulls that energy out to make electricity again. It's just a really simple, powerful loop.
So let's see what this looks like in the real world. A fascinating case study looked at using this exact tech for a green ammonia plant in Oman. And you might be asking, why Oman?
Well, it's the perfect spot. Not only do they have tons of sun for solar power, but they also have huge reserves of the exact kind of ultra-pure silica sand that's perfect for this. It's one of those rare cases where geography and geology line up to create this incredible opportunity. All right, so we've got these two parallel stories, right? On one hand, we're taming tiny silicon particles for amazing new batteries. On the other, we're heating up giant mountains of sand to store energy for the grid. Now, let's pull it all together and see what this actually means for the future. When you put them side by side for grid-scale storage, it's not even a contest. Lithium-ion batteries, super expensive. They use rare, hard-to-get materials, and they wear out. Sand storage? It's the complete opposite. The cost is dirt cheap. The material is literally everywhere. And these systems can just sit there and work for decades. And all of that leads to this. This is the number that really matters. This is what proves that storing energy in sand isn't just a cool science project, it's a flat-out economic game changer.
So remember that study in Oman? This is what they found. If they used sand to store energy instead of giant lithium-ion battery banks, the cost of producing green hydrogen dropped by nearly 60%. 59%. That's not a small change. That is a massive, industry-shaking number that suddenly makes clean fuels way, way more affordable.
So it all comes back to sand. It's kind of amazing, right? From the tiniest particles of silicon inside a next-gen EV battery to a literal mountain of hot sand keeping the lights on for a city, this one super common material could be the key to solving two of our absolute biggest energy problems. We're talking about a future with way better EVs and a green energy grid that's not just reliable, but actually cheap. It just makes you wonder, doesn't it? If we can find all this potential hiding in something as ordinary as sand, what other world-changing secrets are just sitting out there in plain sight, waiting for us to notice?